To André, who is our next speaker, if we may.
Yes.
André is from the University of Porto, Portugal, revisiting and recoding classic algorithmic art. Over to you, André.
Thank you. So, hello, my name is André Rangel, and I am here to present the paper Revisit and Recoding Classic Algorithmic Art and my intermediate installations 3.11 and 3.11 exp. Early in 2017, 3.11, an intermediate artwork that revisits and derives from LeWitt's variations of incomplete open cubes, was designed, produced, and presented with four main objectives: to concentrate the presentation of all 122 variations on a single electronic visualization system, to use contemporary mediums not used by LeWitt due to their unavailability at this time, and to emphasize the algorithmic dimension of LeWitt's work that has been mainly acknowledged as conceptual artist, and above all, to develop and present attributes and their derivation from LeWitt's artwork. To present the different materializations of the 122 possible variations, LeWitt used several media: wood, aluminium, photography, and drawing were LeWitt's choice to present simultaneously bidimensional and three-dimensional visualizations of the variations: 122 sculptures, 122 photos, or 122 drawings. For 3.11, light, one Arduino microcontroller, two potentiometers, 12 analog relays, and visitors were the chosen mediums to constitute an interactive artistic experience that allows one to visualize any of the 122 LeWitt variations on the same display. I will show you now two audiovisual documents of the previous demonstrations of the work. 3.11 is an intermediate provocative and reactive electronic visualization system that triggers visitors' actions, transforming them into performers, co-authors, and mediums of the artwork itself. Frieder Nake, one of the top 5 most acknowledged alive computer art pioneers, stated that insofar, algorithmic art is the mother of conceptual art. This statement grounds the proposal that LeWitt was in fact an algorist. LeWitt has been mainly acknowledged as a conceptual artist, but in variations of incomplete open cubes, his idea, machine that makes art, was an algorithm. It is easily verifiable that LeWitt created algorithms. This conjecture becomes evident when the author himself states, to work with a plan that is present in one way of avoiding subjectivity. It also obviates the necessity of designing each work in turn. The plan will design the work. Some plans will require millions of variations and some a limited number, but both are finite. Despite LeWitt not using the word algorithm, the above description and the chosen words to do it are similar or common to the words used to describe what an algorithm is. This idea that LeWitt in fact created algorithms is corroborated by several authors. Harper Seth wrote, LeWitt developed processes of creating art that conform very closely to the mathematical definition of an algorithm. And Taylor, in 2014, wrote, selecting the basic form and rules that would govern the solution to the problem, as LeWitt wrote, describes perfectly the algorithm procedure. Referring to LeWitt's famous statement, the idea that becomes a machine that makes art, Armstrong states, in this way, the instructions are the core of the project, the algorithm. Doddridge in 2016 also stated that LeWitt implemented algorithmic logic in the realm of artistic production. And in 2017, Gamewell also acknowledged LeWitt as an algorist when he stated that Saul LeWitt was the most methodical of the American algorithmic artists. Beginning in the early 1960s, he produced artworks by establishing a vocabulary, operations, and then carrying out the permutations. Indeed, for LeWitt, the algorithm is the artwork. So, the idea that LeWitt was an algorist, it's corroborated by several authors, and my installation reiterates it. It's not the interest of the current speech to discuss and distinguish algorithms from concepts, but when the algorithm that integrates 3.11 was designed, LeWitt's variation of incomplete open cubes was considered as the result of an algorithmic arrangement. 3.11 doesn't use LeWitt's algorithm, but its result, the 122 drawings that depict 122 incomplete isometric perspectives of a cube. LeWitt presented the variations grouped according to the number of edges, 3, 4, 5, 6, 7, 8, 9, 10, and 11 edges. In 3.11, the result of LeWitt's algorithm were transformed in a database stored in the non-volatile memory space of an Arduino board. While coding the database and the instructions for the Arduino board, an error was noticed on the most widely spread diagram of LeWitt's work. The diagram was published in 2001 book Saul LeWitt, Incomplete Open Cubes, edited by Nicholas Bohm. I continued my research and found that the diagram was originally published in 1974 on the catalog of the first exhibition of variations of incomplete open cubes. Saul LeWitt, Incomplete Open Cubes, the John Weber Gallery. Here is the page with the original diagram on the catalog, and let's zoom to the error. And the most interesting thing is that the mistake is repeated twice on the same catalog. The variation 815 that should have 8 edges is represented with 9 edges. Was it a mistake? However, the sculptured version has 8 edges. I wasn't comfortable and I continued to question myself. How and why is the diagram with the error the one that is the most widely known and used? During the research I did for a previous paper, I concluded that although LeWitt's work was posteriorly revisited by other researchers and artists, none of them has identified the mistake. During that research, I found a paper from Natasha Roskovskaya that wrote a very interesting article in this respect, titled, Is the List of Incomplete Open Cubes Complete?, where she presents an algorithm designed to check the completeness of LeWitt's list. Roskovskaya concluded that LeWitt found the correct number of structures, that is 122, but she and her software did not notice the mistake on variation 815. However, it is worth to mention that Roskovskaya did not consider the diagrams as she wrote me on a personal email. I would like to make a comment that for our project, we never considered these tables of hexagon diagrams, since our goal was to check the completeness of the list, and these diagrams are the least convenient presentation. As it is mentioned earlier, actual sculptures and 3D diagrams do not have this mistake. It is new for me information that in this table of diagrams there is this additional mistake. Thank you very much for sharing this. On the same email, she writes, after receiving your message, I went to our library and checked 2 catalogs that we used earlier for our project. We have both at our university, from 1974 in John Weber Gallery and from 2001 edited by Nicholas Bohm. For your reference, I attached scan of related pages from both publications. As you can see, both publications in the list of axonometric diagrams have this extra leg in variation 815 that you discovered, while photos of sculptures and 3D diagrams do not have this mistake. Thus, I believe that you can be sure that this is not the editor, Nicholas Bohm, responsible for this mistake, and quite safely assume that Sol LeWitt was responsible himself at the time of publication 1974. Even if he asked someone to draw the diagrams, he surely was to check the results, so at least he himself did not notice it. Later that year, thanks to my friend Miguel Leal, I found a book with the correct version of the variation 815. So LeWitt, it's the title of the book, Dibujos 1958-1992, from the Foundation Antoni Tapies. LeWitt is an acclaimed artist since more than half a century. Variations of Incomplete Open Cubes is one of his major works, and the mistake that I pointed out occurs in LeWitt's most widely spread matrix of diagrams that depict the 122 structures. This raises an important question. How come that no one else noticed or pointed this mistake before? It seems that for decades, this artwork was mainly considered in its cultural level, not on its algorithmic or technical dimensions. And even on the cultural level, the work has mainly been considered just superficially. Oman 2016 states that we will articulate a superficial hermeneutic as a condition of both our superficial communication environment and the superficial relationship that the public has with that environment. Art is indeed part of the environment. Historians, critics, and academics are simultaneously public and part of the environment. So the answer to the question above is that no one has noticed the mistake before because there is a tendency towards superficiality. Art history itself, grounded on Oman, needs to be superficial because so much of what audience experience is the banal experience of visual surfaces in various social spaces. One could see superficial hermeneutic as a protocol of display. Superficial art history emerges because it prefigures exemplarity because the surface, superficial, differentiates artist and audience, and it emphasizes technology and material. How many art historians, art critics, art lovers, art students, or general public really grasped which rules constitute variations of incomplete open cubes algorithm? And what is at stake in this classic artwork? Very, very few. Recode. Nake, in his teaching activity, proposes his students a recoding exercise. They observe a classic algorithmic artwork, for example, a George Nee's work, and they are requested to imagine how the work was achieved. In this process, students have to analyze an image that results from one or several algorithmic iterations. From this analysis, students establish and order a set of rules that, when executed, result as an image of the same kind or style. So, Nake sees coding as the activity of describing an algorithm in the form required by some programming language, and recoding as the activity of trying to reconstruct the code of a drawing. Recode is also the name of an online project started by Matthew Epler to bring historic works of computer art back into the public eye. On this website, one can find several classic algorithmic artworks that were revisited and recoding using a programming language processing. This approach enriches the understanding one can achieve from those artworks because the result of the algorithm image and its description code are both accessible to anyone. This approach somehow actualizes the existence of those classic artworks in the contemporary art context by transforming them into new media artifacts, as described by Lev Manovich in his The Language of New Media. I can show you very quickly an example. For example, revisiting the work from Vera Molnar, where you have got the code. You can run the code and see different iterations of it. You can change the code, for example, and just make a different, you can change the size and run the code. So in fact, the practice of recoding classic algorithmic artworks opens a vast field of possibilities to adapt, transform, and derivate from them into completely new artifacts. From all the possibilities, the original classic algorithm artwork is remembered, revisited, and better understood. Copying. Copy as a learning method. Recoding can easily be related with the thought and practice of reverse engineering as a reproduction of another manufacturer, programmer, artist's production following a detailed examination of its construction, composition, and production strategy. Both reverse engineering and recode imply the deconstruction of an object, artifact, or process, and consequently the gaining of a deep and accurate information about it. Copying also relates to and with recoding and reverse engineering. Copying was and is used as a strategy and tool to enhance learning in several fields of knowledge. Humans need to copy when they learn how to write and to read. Copying is still an efficient strategy to develop technical skills on a wide range of human activities. Jordan and Weston, about art and painting education in Japan, state that at each level, student achievement is measured by the ability to replicate a technique flawlessly. Copy is highly antithetical in the field of art education, among other reasons, due to distinction, individuality, and originality needs by artists. Schiff, when discussing the definition of the term copy in the Dictionnaire de l'Académie des Beaux-Arts, the exact imitation of the work of a master as a means of study, copies are of genuine importance in the education of artists, and concludes that individuality surfaces even the copy. So, undoubtedly, recoding has a highly pedagogical value, both in terms of deepening knowledge about what classic algorithmic artists did, but also in terms of skills development by the individual that recodes. Recoding becomes a way of appropriation of language. When someone appropriates language, they make it their own, opening new possibilities for self, individual, and distinct expression. It's worth to underline that in 3.11, the aim was not to recode the original LeWitt algorithm that originated 122 variations, but instead, and specifically, the intention was to recode the media display of those variations. Even by just recoding this layer of the artwork, it was possible to discover the mistake on variation 815 and to design a new distinct artwork derived from LeWitt's original. So just a quick note on the title of the artwork. The variation which has got here is variation 815, and I choose to name it 311 because 3 is the minimum number of edges in the diagram and 11 is the maximum. And by coincidence, it's my birthday. I was born on 3 of November. Thank you very much.
Well, thank you, André. There's a very thought-provoking and many concepts and many ideas there for us to take in. Yes, we have one or two comments, like perhaps we need someone to actually check out all our editing on that or on things. But that was fascinating, and I greatly appreciate it. Let me just see if there are any particular comments from people. I don't think there's anything in particular at the moment. If any of you would like to take up any points with André, perhaps, or André could check the chat and respond to you. But I think as we're running nicely on time, thank you